When we start research, we review something and we synthesize what has been already explored before or what is the existing knowledge. And we investigate some existing situation or problems. For example, somebody has proposed a technique of identification of a person. Then we explore new things in that, and we see what are the existing situations or problems which have been already proposed by the people. Then we work on that and we explore something new. And we provide solutions to a problem. This is very important, of course. Every research should be solution oriented. It should give some solution at the end, of course. And explore and analyze general issues. If one of the very important purposes is to explore and analyze, to find new thing and to analyze what has been done on the general issues. And what we have to construct a new procedure or a system. Of course, research will construct a new procedure or theory or a system or application or a software. And explain new phenomenon, facts. This I told you before that the purpose of the research is to explore facts or discover new thing and generate new knowledge. This I have already told you that it generates new knowledge, increases the knowledge. Okay. And normally people think that this is also one of the research. It is combination of two words. Re means repeat something, and search means to look for something. So basically, if you see the idea of the word of research, it is taken from these two words, re and search. And so much of interest has been built upon existing work, because most of the people and we are doing research based on the existing work, what has been done. Like somebody is using the theory of wavelet theory, somebody is using the theory of automata, somebody is using the theory of relativity. So what has been already done by the other scientists, we are just developing our new theories on the basis of those existing theories. And therefore, a thorough understanding of those ideas is the basis. We should understand those ideas before, then we can propose our ideas on the basis of those ideas. And too many smart people in the world, like I give you the example of biometrics. There are a lot of hundreds of people are working in the biometrics field, and a lot of papers are every day. A lot of papers are coming in IEEE and so many transactions and Springer and elsewhere. So many people, and they are doing a lot of research. So we are also, maybe whatever I am thinking, they are also thinking on that. And I face this problem so many times. When I was going to file a patent, then I made whole procedure, everything I discussed with the professors, and then we went to the patent attorney that we are going to do this thing. But later on we found that this has already been done by the other people in USA. So a lot of people are doing a lot of things, and it is, what we are doing in the research is rethinking it again and again and again. So an iterative process. And just I told you that it's an iterative process, and we see what is it and why it has not been done. There are so many areas. Okay, what is the logical connection with the existing approaches? For example, we are going to propose a new thing. We have to see the logical rationale between the two approaches, what we are going to propose and what has already been proposed in the literature, right? And actually research is a linear process. If somebody has question, then maybe can raise hand and I can again explain it, okay? And it's a linear process in which first we identify a problem. What is identify a topic? What is the topic? For example, I want to pursue research in information security. Okay, this is my first thing. I identified the research topic, information security, right? And define research problem. Okay, I want to do research in information security's biometric area. Biometric is newly technique of identifying a person. Okay, then I identified a research problem. The research problem is that I want to improve the accuracy or recognition performance of fingerprint identification system. Okay, this is my research problem, because many systems cannot overcome the problems of identification when there is a scar or where there are cuts on the finger. Okay, and determine how to conduct research. Now I have to identify, I have to determine that how can I conduct research in this area, how can I come up with the new algorithms, new ideas. Then of course what I have to do first, I have to look for the literature. I have to see the data, research data which has already been proposed by some researchers. A lot of papers, I can search from the elsewhere, from Springer, from IEEE, or from different databases, right? And I have to analyze and interpret the research data. I have to understand what they have done. I have to analyze it, what they have done. That's the reason when I will understand those ideas or those techniques, then of course I will propose my own technique. If I don't know what they are proposing, then how can I come with a new idea? So it's very important to analyze and interpret the research data which has already been proposed by some other researchers, right? And then propose a solution. When you have analyzed things, then you are going to propose your own algorithm, your own strategy, your own mechanism, or your own framework. So this is discovery. This is your creativity. This is your research here. Are you getting my point? And then, of course, when you have discovered something, then at the end you are going to write dissertation or report or research paper or whatever, or a technical white paper or whatever, right? So this is the basically a linear process. Research is followed in this whole steps. Right, now we depict you the figure of this linear process. As I told you that our main objective is to discover. The discovery is the most important parts of the research. So we have to investigate by careful study, and our objective is to discover something. Okay. Now we see here, like I told you that first we define some problem. Okay, then define the search on that, and then we ask these questions to ourselves. What is the problem? We are going to solve this thing. Okay, why it is important? Because it will improve the revenue of a company. Of course, if this company, for example, biometrics company, Technologia, is going to propose a solution of that we will have 95% fingerprint identification system. So why they are doing this thing? Because they are going to improve their revenue. They will sell, everybody will buy this system. Okay, this system is reliable and trustworthy. It will be very useful for us. But other systems are proposing 90% accuracy. So it means that why you are doing here is that you are going to explore new thing, and you are going to improve the performance of the system, and ultimately you are going to improve the revenue of your company, right? And how you will do? Of course, when you have come up with this thing that, okay, I will improve the performance, but how? Which algorithm I will use? Which technique I will use? This is very important thing. Means research is mostly based on W's and H's. What, why, when, how? These kind of questions you ask in the research. So this is basically, and where, of course, where it will be implemented, who will be the, my potential user, where it will be used, in which environment it will be used. So this is the questions. When you identify this question, then you start searching, investigating. You see it's a maze. It's just kind of a M-A-Z-E maze. You are just going iteratively and doing some work here, and it's a very complex process. Then at the end you come up with a discovery. Then you discover something. And I tell you that sometimes you become successful, sometimes you are unsuccessful. But every negative result is positive for others. Because every negative result, you achieve some negative result. This is not good. But it will be positive for others, because if you will tell them, this is my research, this has constraints here, you don't do this thing, then people will not do. People will save their time. So negative result, what you achieve will be positive for the other people to save their time. Okay? So whatever you discover, the very important thing is to communicate with the community, with the people, to publish it. If your research is not published, if you have not published your paper, if you have not filed your patent, then what is the benefit of doing research? You have to publish it, you have to present it, you have to file it somewhere, right? You have to archive it somewhere. So this is very important also. After discovering, you have to communicate your investigation with the people, right? This is, sometimes we face this problem, especially when we are doing PhDs or masters by research like this. There are actually 4 cases of research. Normally we have seen in our life. That new problem and new solution. It's, Boolean logic. 1, 1, 1, 0, 0, 1, 0, 0. It's a Boolean logic in research. That new problem and new solution, this is very rare. It's a breakthrough in the research, in computing and engineering, right? Like Shannon's theory. It's a new problem that I am going to propose a information theory model of, in the computing and communications. And I am giving the new solution of entropy for that. So it's a new problem and the new solution for that. But it's a breakthrough and it's rare. And case 1 comes rarely, perhaps something you could only wish once in your life. It's like, for example, Shannon's theory. Like he gave his theory in 1949. And maybe some people who are from electrical engineering background have read that paper. Must read that paper. Without reading that